discuss about the problem sums related to speed regarding quadratic equation chapter. Okay, so each year in the ICSE boards exams, okay, we find the questions which are based on problem sums. One question comes particularly from quadratic equation. So it could be based on speed, it could be based on two-digit questions, age questions. So there are different topics. Okay, so let me discuss about the concept of how to solve the questions based on speed in case of quadratic equation, right? So first of all, you know that speed is expressed as distance by time. Okay, so time can be expressed as distance by speed. So this will be your formula. Okay, distance by speed. Okay, so remember to frame the equation in terms of time. Okay, you know time is inversely proportional to speed. Time is inversely proportional to speed. Okay, that means if you increase the speed, the time taken for the journey will be less. Okay, and if the speed is decreased, the time taken will be more. So these two concepts have to bear in your mind. Okay, now let us discuss one question based on the speed. Okay, a bus covers a distance of 240 kilometers, okay, at a certain speed. Okay, now due to heavy rain, okay, the speed of the bus is reduced by 10 kilometer per hour. Okay, so it takes 2 hours more to cover the same distance, that is 240 kilometers. Find the normal speed. Okay, now one thing please keep it in mind that when you want to assume x, okay, you have to read the last statement. Okay, whatever is asked in the last statement, okay, you take that as x. So the moment you get the solution set of x, the question ends there itself. Okay, so we are taking the, now this is the solution. Okay, how to solve? Let the normal speed be x kilometer per hour. Okay, remember the speed has to be in kilometer per hour so that you get the time in hours, provided the distance is in kilometers. Okay, now time taken t1. Now t1 is the original time taken when the speed was x kilometer per hour. Applying this formula, time equal to distance by speed, the time t1 comes to 240 by x. Okay, so this is one equation. If the speed, now the second part of the statement says due to heavy rain the speed of the train is reduced by 10 km per hour. So the speed t2, the speed will be, this is the new speed. New speed is, the x was initial speed, it is reduced by 10 km per hour. So this is the new speed. So what about the new time taken? The new time t2 equals to the same distance 240 is now covered with this speed. Okay, this is the time t2. Now you see, when the speed is reduced, the time taken is more. So now you are going to frame the equation t2 minus t1 equals to, the time difference here is given 2 hours more. See, this is 2 hours more. Okay, so apply this equation. Now put the values, 240 by x minus 10 minus 240 by x equals to 2. Okay, if you frame the equation correctly, you will get the factors and the answer will be absolutely correct. You can check it at the end. Okay, now you can take 240 common. Take 240 common. Don't make the calculations complicated. So if you take 240, factorize, it is 1 by x minus 10 minus 1 by x equals to 2. Now this brings the equation x into x minus 10, and in the numerator we have x minus x plus 10. This is equals to 2. 240 goes here, so it cancels. That is 1 by 120. Okay. Now the equation becomes 10 by x square minus 10x equals to 1 by 120, and the equation comes x square minus 10x minus 1200 equals to 0. Okay. Now if you apply the middle term concept, we get the factors x square minus 40x plus 30x minus 1200 equals to 0. That brings x within bracket x minus 40 plus 30 within bracket x minus 40 equals to 0. So the factors are x minus 40, x plus 30 equal to 0. That brings the solution set x equals to 40 or minus 30. Since the speed can't be negative, so this is inadmissible. So we are taking the normal speed x equals to 40 km per hour. Okay, you can check at the end. Just put the value of 40 over here. Okay, so this time t1 was 240 by 40. That is the time taken for the first journey. 240 by 40, it comes to 6 hours, right? When the speed is reduced by 10 km per hour, in this the time t2 comes 240 by 30, and that is 8 hours. So the answer is absolutely correct. The time difference is 2 hours as given in the question. So you can check it at the end also whether the solution is correct or not. One thing very clear to be mentioned, the way you frame this equation, that's more important. When do we apply t2 minus t1 and when we apply t1 minus t2? Suppose in the same question, okay, the speed has been increased in the second part. Okay, the original speed was suppose x, we took it like this, and in the second part of the journey the speed has been increased by 10 km per hour. Here the question says reduced by 10 km per hour. What would be the situation if the speed is increased by 10 km per hour? Okay, then in that condition the new speed will be definitely x plus 10. So the time taken for the second journey will be t2, that is x plus 10, and the value of t1 is same, 240 by x. Now what you have to do? You have to apply this formula, t1 minus t2 equals to 2 hours. Why? Because when the speed increases, the time is reduced. So the second time interval is less than the first time interval. So the equation will run like this, 240 by x minus 240 by x plus 10 equal to 2. A slight error in framing this equation. Instead of t1 minus t2, if you do t2 minus t1, you will get a wrong expression. and that will fetch a wrong result. So once again, let me discuss. The time is inversely proportional to speed. The speed increases means time reduces. Here, when the speed increased, the time reduced. So we applied T1 minus T2 equals to 2 hours. But here, the speed reduces means time taken is more. So T2 minus T1 equals to 2 hours. So to be very clear, the questions on speed has to be framed in the correct order. I think the way the solution has been exposed is very clear to you. I am providing some questions, okay, which will make you more perfect. When you solve those questions, you will come to know both the situations, when the speed increases, when the speed reduces, right? So let me share those questions so that you can find easy for you. Here are the questions, okay? Now see, we are going to discuss the same pattern of questions, okay? As we solved the questions based on speed, we are going to solve questions based on the same pattern, okay? Now, suppose a question is there, rupees 480 divided equally among X children, okay? Okay. Now, if the number of children, were 20 more, okay, then each child would get rupees 20 less, okay? Find this number of children, original number, okay? Find X. Now, the pattern to frame the equation, the method to frame the equation is more or less like the questions in speed, okay? Here also, we are taking the same concept because you have to find X. Now, initially, the share of each child is 480 divided by X. This is the share of each child, okay? 480 is the total amount, X is the number of children, so each child is getting this much, okay? Now, the new number of children, when 20 more are there, increased. So, the new number of children is now, because X is the original number of children, the new number of children is now X plus 20. The number has increased by 20. So, the share, this is the new share of each child. This is equals to 480 is now divided by X plus 20 children, okay? This is the share of each child, this is the share of each child. Now, as we compare in speed questions, when the speed increases, the time reduces. Here also, when the number in the denominator increases, the function, the value of this becomes lesser, okay? So, here we can say, as per question, okay, we have 480 by X minus 480 by X plus 20 equals to, now each child is getting 20 more, okay? That means the share of each child is more by the share of each child by rupees 20, okay? Now supposing if, I think you can solve this equation, take 480 common, that will make more simple. It's 1 by x minus 1 by x plus 20 equals to 20. Shift this 480 on the right hand side, so it is 20 by 480. Here we have x into x plus 20. On taking the calculation by taking LCM, we have x plus 20 minus x. These two get cancelled. So we have, here we can make it more simple. It is coming 24. So upon cross multiplication, okay, we have the equations reducible to, suppose this is x square plus 20x, okay, minus 24 to 480, okay, equals to 0. So after this you can solve the equations. Clear? So our main focus is basically we are getting the equations up till when we discuss this and we make a clear conception which one to subtract. Now supposing if the number of children has been reduced, take the second case. If x was the original number of children, okay, and the new number is reduced by 20, instead of increasing we have reduced by 20, okay, then the equation will become 480 by x minus 20 minus 480 by x equals to the share of each child, okay. So remember, when the number is reducing the denominator, the value becomes more, okay. So this is how we had done in the questions based on speed also. Clear? So this is how we can apply, and based on this we have questions that is given. You can refer here. These are the questions which are given based on what we have discussed just now. So the pattern of solving the questions on speed is same as in this. There are at least 12 to 15 questions in your textbook. You can refer to that. The answers are given alongside so that you can check it out. Okay? Now pay attention. We have questions on upstream, downstream. But these questions are not same to be solved as we have done in normal speed questions, okay? Upstream and downstream. Now this you have done in class 9 also in simultaneous equation chapter. What is upstream and downstream, okay? Suppose a boat is traveling with a normal speed of x km per hour and it is moving along the direction of the stream, okay, then this is called the downstream motion. Clear? So in this condition, if you take the speed of the stream to be y km per hour, okay, then the equation will become time for downstream, that is ds, equals to distance. Suppose with this speed it is traveling a distance d1 and for which the time taken is t1, right? Then we can say it is d1 by t1 equated with x plus y, okay. So the time taken for downstream will be d1 by x plus y, okay. Now of the two, you will be given the speed of the stream or speed of the boat, any one, okay. That means either you will be asked to calculate x or y, okay, because quadratic equation deals with one variable. There are no two variables like simultaneous equations, okay. Now in case of upstream, this is for the downstream, okay. Now let's compare with this upstream. Upstream means the boat is moving against the stream. Suppose the stream is having the same direction and the speed is y km/h and the boat is now moving against the direction of the stream with the same speed, that is x km/h in the still water. Then in this case, time taken for upstream, okay, this is given by the formula T2 equals to d2 by the time s2. See, we are comparing the speed, that is x minus y, because the speed with which the boat is moving is the difference of x and y, okay. So this is the relative speed with which it is covering a distance d2. Suppose this is the distance d2 and for which the time taken is t2, then we have this formula. So the time taken, let it be t2 for upstream, then we can apply the formula d2 by x minus 1, right? This is equation 2, this is equation 1. Now suppose if the same distance is covered upstream and downstream, we can replace this d1 and d2 by d, okay? So the questions are given like this: the total time for the upstream and downstream, the total time t for downstream motion and upstream motion is given. So we can equate t equals to t1 plus t2. That means the total time taken for downstream and the total time taken for upstream. That means here this is suppose t1 and here we have t2. So now we are placing the equation, the total time which is given equated with time t1, that is d by x plus y plus d by x minus y, okay. You will be provided the speed of either boat or the stream and the total distance, that is the time taken for the downward distance and time taken for upward. The total time will be given to here. The distance will be provided. The downstream upstream motions, if both the distances are same, you can replace d1 and d2 as d, as I have written in this equation. But supposing if the distance for downstream is separate, distance for upstream is separate, you take d1 d2, okay. So whatever is this, we can say we are equating the total time. So this question for downstream upstream motions are totally different from normal speed motions, okay. So this is the way you can solve this. Thanks for watching.